So, hello everybody, and welcome to the next in our conversation and coffee on this occasion with consequential robotics. And today's conversation is going to be about blended learning in universities with MiRo. And I'm delighted to have my two guests with me here, Alex Lucas from the Department of Computer Science at Sheffield University, and Professor Tony Prescott, who is Professor of Cognitive Robotics and the Chief Scientist at Consequential Robotics. And I, of course, am David Lane, and I am the Executive Chairman of Consequential Robotics and Professor of Autonomous Systems at the Edinburgh Centre for Robotics at Heriot-Watt University in Edinburgh. So, hello, Tony. Where does this find you today?
Yeah, so I'm still in Sheffield, enjoying daylight for the next few hours. But yeah, the sort of December's looking a bit brighter than November was.
Yeah, wonderful, great. And then Alex, hello, where does this find you today?
Same place, Sheffield. So I think, although I'm a bit different part than Tony, but it's still quite sunny and nice. So yeah, it's very good today.
Cool. And I, of course, am in Edinburgh, and it's grey and cloudy, but the sun's coming in and out, which will probably change the lighting on the screen. So, blended learning in universities with MiRo. What is blended learning? As the pandemic has struck, all universities across the UK, in fact across the world, have had to change how they teach. The students are at home or in their halls of residence, and it's never been certain whether they would be able to come into the university, and even when they can, how many can come in and what measures should be used. So all the universities have been working to make their teaching programs responsive in the way that the teaching is delivered, so that it can either be done remotely or, where possible, students can be brought in. And obviously, we want to have as much in contact as we can, because that's good for everybody, but it's not always possible from a safety point of view. And in common with other areas of robotics, not to do with teaching, but to do with use in industry, they have similar challenges about working remotely and indeed doing things at scale with robotics. And the common solution to that, which everyone is working towards, is what some people call digitalization. It's about using the cloud and as the basic means to work remotely, and what we might call cyber-physical infrastructure, having digital twins or models of things that we're working with that we can use remotely. And then when the time comes, work in a living lab or an environment with a robot to download code or to try in the real world rather than in simulation. This is a big trend that's kind of working its way through all aspects of robotics across the world at the moment. And we have a great example here of that in action because of the way that the MiRo robot and MiRoCLOUD in particular is configured, and the way that it can be used to help teachers and educators of universities change the learning experience for students to be working either remotely or in a real laboratory environment. So today we're going to look at some of the features of MiRo that allow us that to take place, and we're even going to look at some extremely interesting, I think, practical examples of that, where in a facility at the Diamond at Sheffield University, where more than 2,700 hours of teaching has been going on, or learning has been going on, with over 300 students using MiRo. So we look forward to hearing about that. But anyway, just to kick things off and set the scene a little bit, Tony, what is it about MiRo that makes it suitable for this blended learning environment that we find ourselves in?
Well, MiRo is designed to be low cost, but relatively high functioning robot. So it has a lot of the things that you would want in a teaching robot in terms of sensing and actuation. So lots of ways of sensing the world, particularly high quality stereo vision, 4 different microphones, touch sensing, and then also ways of moving, so it can drive around and it can move its head and move its ears and its eyelids in an expressive way. So it's essentially a mobile robot with lots of sensors on it. It works out of the box. You don't have to assemble it, which if you're teaching a class with 40 robots would take a lot of time if you had to build them from scratch. And because it's low cost, we can also, at Sheffield, loan them out to students, and some of our students have been taking them back to their halls of residence, for example, to do level 3 projects. But I think what's perhaps most unique about MiRo is that we've developed this simulation environment, MiRoCLOUD, which uses a full physics simulator gazebo. So you can see what MiRo would do in the more or less in the real world. Of course, the real world's never quite like simulation, but you can get close. You can do computer vision in the simulated environment. You can do various other forms of sensing, and of course you can do action. You can move, you can bump into things and so on. You can fall off tables and not smash to pieces and things like that. So MiRoCLOUD, I think it was quite fortuitous that we were in 2019 developing MiRoCLOUD to run entirely in the cloud, so without any installation process. And that was on the back of feedback from our university and others, that the process of installing on a computer was really a turn-off for education establishments, and also just very complicated because you have lots of different computer platforms, and you have a complex installation process, lots of bits of software that you potentially need, and security issues. So we've tried before in Sheffield to do that. It's been difficult. We've tried using existing cloud-based solutions. They generally don't have enough grunt or power to run simulated robots. So we developed our own solution with Amazon Web Services. So what we have is a scalable web cloud-based programming environment where you can simulate the robot pretty much in real time, and you can run your own programs. And so we've been rolling that out as Consequential Robotics since the summer, and it's fortunately for University of Sheffield coincided with taking our teaching online.
Unmute myself, schoolboy error. Great, so effectively using Amazon Web Services, you've got a supercomputer sitting behind your laptop, right, giving you all that computing power to really give you good modeling and be able to work remotely. And then of course download to the real robot. So that sounds like it's something that's going to be really useful in a practical teaching environment.
And what we've found before is that it's really essential to have that multi-user capability. We have 300 students in year one. If half of them are working on MiRoCLOUD at the same time, then that's a lot of computer processing. You know, simulating a three-dimensional world and interacting in it takes a lot of computing power. So most university workstations are more or less up to it, but a lot of student laptops and things won't work with that. And the advantage here is that you just open a browser window, you log into your account, no need to install anything, and you've got access to a fast simulation. Everyone has the same experience. And there's no issue about you're on a Mac, the student's on a PC, will the software work? It all just works through a browser, so it works on any platform.
Yeah. Fantastic. So that sounds like it's going to be really useful. So over to Alex, because you've been teaching various courses in the University of Sheffield Computer Science this year, starting with level 1 courses, and you've been using, interestingly, although we originally conceived MiRo and MiRoCLOUD as a means to teach programming, you're not actually teaching programming. You're teaching level 1 courses in algorithms and architectures. Wow, right? And so this is a robot that you're using, or a means that you're using to actually help with the practical work and the labs, right, effectively in the course that you're doing. So from your point, it'd be lovely to hear something about the kind of things you've been doing and the games you've had the students playing and the way you've integrated that into your teaching. So maybe could you say a little bit about how you've structured the labs and the lessons and the kind of experiences you've had with the students?
Yes, thanks, David. So yes, in Department of Computer Science, we do have first year 1 level teaching, and in particular for the module we have on machines and intelligence, we use MiRoCLOUD quite extensively to illustrate some of the concepts from the module we teach. So in the first part of the module, we teach agent architectures, intelligence agents, starting from simple reflex agents and model-based, goal-based, and so on. And then in the second part, we move on to looking at computer vision and how machines do their vision. And we're using MiRoCLOUD also to touch upon that. So we actually were able to use MiRos and MiRoCLOUDs to do some object detection and recognition, and both in the simulator and in the real world. So actually, I thought I'd perhaps show some pictures and videos from the labs to give our viewers a bit of understanding how it looks like.
Yeah, wow, yes, please. That would be good. You have the screen.
Thank you. Yeah, so hopefully that will work. Right, so first of all, I just wanted to show how it all looked like when we started. So we first started using MiRos last year, 2009, before the pandemic. So these are the good old happy days. So these are just a few pictures. So obviously the students were able to interact with the robots, so they could have actually a hands-on experience and play around with them, have a look at them. But obviously, we won't be able to do it this year, so we had to adapt. So how it looks like now is we have this setup where we have the arena and we have the demonstrators handling the robots. And basically what we do in the face-to-face sessions is students come in, they are obviously all social distance, and they use MiRoCLOUD to work in the simulator. And when they're ready to put their code on the robot, they just connect to the robot they would like to in the arena, or if they want to move a robot to a specific location, they ask demonstrators to do so. And yeah, they can switch between the simulator and the robot quite easily. So this is just a left view of the room, and you can see there's projectors, and we have a setup where we stream the room camera, so you can see it here on the top. And it just shows what's happening in the arena for the students who are quite far away and cannot see immediately what's going on.
Alex, just to explain to switch to the robot, you just have to put in an IP address of the robot.
Yes, that's right, Tony. Yep.
Click a button and you swap between the simulation and the actual robot. And that means that you can share robots between students because they can take it in turns to use that IP address. It also means that you don't actually have to be in the room to connect to the robot. You could potentially be at home, and we've got videos so that students who can't be in the lab can watch on video and see what the robot is doing and send their program and have it run on the robot and see what happens.
Yes, so just this week we actually tested this capability and it seems to work fine. So basically wherever you are in the world, you can VPN to the Sheffield University. And then in there, when you launch the MiRoCLOUD, you can access the robots that are in the room. So basically you can both see what's going on in the arena and control the robot at the same time, virtually anywhere in the world, which is quite cool, I think. So just to give you an example how the session looked like. So this is just a sped up version of the head overview camera. So in this particular example, students were trying to do some ball detection. So just quickly scroll through. As you can see, some balls have moved. Which basically, there's varying progress, but some of the balls were obviously, so you see this one. So MiRo is trying to lock on the ball and trying to kick it off of the arena, basically. And also we have another camera zoomed in, so if you want to have like a more broad view of what's going on and where the objects are, you can switch the view and have this sort of close-up view. So, and this is the further in the year. So in this session, the students were trying to detect, you can see on the blue boxes there's some signs, and the students were trying to detect those signs and kind of wiggle the tail or do some action to indicate that they've successfully detected the sign. And just some highlights. So the student did a program which knocked off these cups. Yeah, so basically you can see it's still doable in the circumstance that we are now, still to kind of emulate some of the face-to-face and hands-on teaching that robotics.
Yeah. So were the students, to what extent were the students working at home, and to what extent were they working in the lab? And were they able to work from home and download and sort of witness the real robot remotely? How did that work out in the end, in this most recent semester?
Yeah, so basically we obviously cannot accommodate all 300 students with the social distancing, so we had to do slots where students sign up, and usually we had perhaps 80 students per week, and the rest were connecting remotely, both during the sessions, so we had maybe 2 or 3 sessions, and obviously the remote students could connect to those as well. And we had students working in groups, by the way, so we usually assign groups of 4. So the students who are in a group, but they're connecting remotely, they could work and collaborate with the students who are in the class and share the code and see what's going on. And we also have another, just an online session on a different day where all the students can connect remotely and ask questions and ask for, support.
Cool. And we're all, it's a level 1 course, right? So were all the students able to code when they started, or how did you handle that?
Yes. So the good thing about MiRoCLOUD is you can actually start off very simple in the Blockly interface, which is a very intuitive interface. And
you want to show that now? It might be useful.
Yeah, sure. I can show it now. It's just perhaps need a minute or two to launch the MiRoCLOUD instance. But yes, you have the Blockly interface, and it's all basically a wrapper code around the underlying Python code. And the blocks are preset with certain actions and movements and, some maths and logic and stuff like that. So it's very quickly and very easy to dive into that. And I just gave some instructions on what the blocks do. And basically, that's all the students need to kind of start going. And then once we are into the second part of the core of the module, we switch on to Python. And again, this is a very unique feature to MiRoCLOUD, where you can transform the Blockly code into Python code quite nicely. So you don't actually have to know that much of Python to be able to program in Python, because you can start off in Blockly, then transform your code to Python, and then just make small changes to the Python code if you want to really fine-tune something.
Yeah, just worth saying, David, that we also did a open day session with some of the applicants in the summer with MiRoCLOUD, and then an intro week session as well. So, and with computer science degrees in the UK, it's usually not a requirement that applicants have computer science A-level. So we get a real mixed range of programming abilities. Some people have done no programming, some people are experts at it. And at the same time as we're bringing people up to speed on their programming in another course, we can teach people about algorithms using MiRo and just using the Google Blockly, which is a visual programming language that really anybody can get up to speed with in just a few minutes.
Great, good. I know that in some of the schools where MiRo is being used, the kids learning to program have been given Blockly, and on their own they've gone to go and play with the more complicated coding just to try and figure it out. So it's kind of like their own creativity, which is before that, which is one of the great things about MiRo. You can be creative.
I think the visual programming language is great for getting going, but then once you become a bit faster at it, you want to be able to get in data parameters quickly, and the Python's good for that.
But the good thing was you didn't have to teach them Python; they just went off and did it.
Yeah, exactly. Yeah.
And I think that was your approach, Alex, wasn't it? That this isn't. I'm not going to teach you programming. And
I can help with bits and pieces. Yeah, but I'm not teaching you Python. So this is
exactly. So that was improved. Anyway, what's happening on the screen here? We've got.
Yes. So this is actually. So you talked about creativity and how level 1 students can be creative. So I didn't anticipate this at all. So this is a submission for one of the assignments.
Wow.
Where basically the students have to program MiRo to go and explore this environment and reach the stop sign at the end, and obviously not fall off a table. So they have to program this, but this is just one outstanding submission. So as you can see, you can go quite far away in Blockly if you're really willing.
So these are function calls, each of the individual components?
Yes. So just kind of give a breakdown. So the violet or whatever color this is, so these are all functions which students have programmed on their own. And other colors are mostly blocks that are preset. So these are the movement blocks. These are some comments and outputs in the terminal. So yeah, there's lots of stuff going on.
And
so
where's the main program loop in that then?
Yeah, so let me try to find this. So this is the main program loop, which periodic control loop. So this is where you check the sensors and the readings coming from the MiRo each 10 times a second. And based on that, you just kind of do the stuff you own. So yeah, so this is the main loop, and students just do task 1, task 2, and so on.
Yeah. So just to be clear, Alex, most students, when they start out, write something that looks like that main loop about, you know, a dozen or so boxes.
Yes.
But the ones that really get into it, and there are a few, can do thousands of blocks and really build quite exciting, interesting programs.
Indeed, yeah. So there's some built-in templates, so I just show how a typical program to illustrate some of the functionalities would look like. So as you can see, it's just a handful of blocks, really. Yeah, and the good thing, as I said, where you can transfer this to Python. So it's
so Alex, with those blocks, what does the robot do? Maybe you could run one of the programs just to show.
Sure, yeah. So I won't run that long one because it might take a while. But for example, this one. So what we simply do is click play. And obviously, when you have the physical robot, you can just type in the IP address. And instead of using this control panel, you control the robot directly. So this is all the difference, really.
Right.
Quite cool.
Can you zoom in a bit? That's it, yeah. So we can see MiRo on a table there.
Yeah, so basically what it does is it raises its head and looks left and right. It does this motion. Yeah. And there's a square dance, for example, when it just goes in a square.
And that's pretty much real time. Would be the same if it was on the physical.
Yes, yes. So you can see the timers here. So there's a slight delay, perhaps 0.9 speed or 0.95, but that's really barely noticeable. Yes, it's almost real time simulation. So quite quick and quite effective. So
sorry, it's real physics as well. So if he was to come to the table and fall off, he wouldn't break to pieces, but he would sort of fall to the ground.
Yeah, so let me just illustrate.
Cylinders, you'd see them fall over.
So I'll just tell MiRo to quickly go and fall off the table here very quickly. So actually, there's a setting there which by default does not let you do this. But if you're really persistent, you can actually do this.
Yeah, just to tell people not to do this with the real robot.
Indeed, yes.
It's not guaranteed for falls from tables.
Yeah, this is live programming, folks. Unrehearsed.
Whoops. Yeah, there we go.
Whoa. Full physics. MiRo falling off the table. Wonderful.
Yes.
Good.
So sometimes, obviously, it lands on the wheels, so as it should, and then it just carries on doing whatever it was doing, which is quite fun.
Well, we don't have a self-writing mode in MiRo at that point. You have to resort to other tactics. Yeah. So, Alex, I had a question. Some of the examples you showed of the students using it were using sort of computer vision to spot red balls or whatever. How did you go about implementing the vision modules? Where did that come from, and integrate that into Python or Blockly and make it available to the students?
Yes, so there's some preset blocks on vision actually built in Blockly. So I'll just open the interface so you can see some of those. I'll zoom in a bit. Oh, too much, sorry. Yeah. So some of the pre-built stuff you can do is you can find a bolus-specific color on left or right camera images. You can, for example, detect the face ID of this MiRo cube. So each face ID has a different QR code, and you can estimate basically at which angle, at which point you look at this MiRo cube. You can also try and detect shapes of arbitrary kind of polygons of arbitrary sides. So for example, this has 8 sides, the stop sign. So you can try and find this sign using this block. Basically, all kind of their underlying machinery uses ROS and Python and OpenCV libraries.
Yeah.
So basically what you can do is, if you really want to fine tune these algorithms and try something else, you can just convert some of these codes into Python and just replace the built-in functions with the functions you develop on your own. And I've
underneath it's got OpenCV, which is sort of the most widely used computer vision library. So you can access everything in OpenCV in the Python. And if you look in the simulation screen, you can see what MiRo sees in the bottom right-hand corner there.
Yeah.
Those are the actual views of the two cameras. And they're quite high-resolution cameras, so you get quite a good image. And because you've got two cameras and there's some overlap, you could potentially extract depth through stereo. So you could get distance as well. So you can do a lot with the computer vision without actually having the robot. But of course, you could then put it on the actual robot and control your robot to move around using the visual signal.
Perfect.
Yeah, that's right.
Great, so that's really good. So that means, I mean, Tony mentioned at the beginning all the sensors that are on MiRo as well as its actuators, but with all the open source software that's around, a lot of it using ROS, OpenCV is not the only one, there's plenty of other ones. Yeah. You can really build in quite a lot of power. And it's the power of open source software that can be integrated onto MiRo and into the MiRoCLOUD environment. That means the sky's the limit. And you know, it's all about your creativity of the students ultimately, or indeed the teaching staff as well. So that's great. So that was a level 1 course, but of course we can use it for other kinds of teaching as well throughout the curriculum. And I know, Tony, you've been doing some other things with level 3 courses. What experiences did you have and how well did it go?
Yeah, well, so Alex and I are teaching a level 3 course called Cognitive and Biomimetic Robotics. Clearly, MiRo is a biomimetic robot. It's designed to look a bit like an animal, but more importantly, is designed to think a bit like an animal. So its control architecture is modeled at a very high level of abstraction on how the brain works. So we teach some of that in the level 3 course. And I think that illustrates how robotics can be used to teach concepts in biology as well as concepts in computer science. So we can tell students a bit about how brains work as well by showing them how this robot is programmed. We also use these robots for undergraduate projects. So we have level 3 students doing projects, myself or Alex supervising, or other supervisors, and there's that's a project you do over the course of 2 semesters, so you go into quite a lot of depth. People often install the full MiRo developer kit on their own computer for that, which gives you a lot of flexibility about how you program it. And we do group projects as well. So if I can share my video, we've done some work, for example, on robot football. So this is just from a couple of years back. And I don't know how much you know about the state of the art in robot football, but robots aren't very good at football. And MiRo is certainly a bit of a beginner. And this was the first time we really tried to do robot football. So this is a couple of students who managed to program the 2 robots to do a sort of a set piece, a sort of corner kick. And you'll see it's a little bit slow, but this is real time. Cool. So some students very obviously happy with the outcome there. So that was some of the projects we've done. We've done lots of different ones now, looking at particularly using computer vision. We had one student who did a project on reinforcement learning using stereo vision, and that was published at a paper in a robotics conference. Actually got nominated for a best paper award. And one of the advantages of MiRo being low cost is that we've been able to lend out MiRos to students while there's been, even through the lockdown and through COVID, so that they can take one back to the Hall of Residence and work on their project from there. So that's a unique advantage, I think, of MiRo. You don't need any extra kit. You just have MiRo. You need Wi-Fi, and you can run it from your laptop, and you can do your project from there. You're on mute.
Another schoolboy error. And that's the benefit, that's the real power of this. The things that we've learned to do during the pandemic, because we had to, are actually things that we're probably going to keep doing because it's good for the way that students learn. And that's kind of what we want to do. And this whole student-centered learning idea and the way that we can introduce creativity and do practical work remotely and at scale, 300 students, from China, I think, Alex, you were saying earlier on, through a VPN, they came in to do it. These are really powerful ways of working that are going to map to how we teach in the future. And not just for students, young students in universities, but people throughout their lives who want to learn new skills and retrain and reposition themselves in their lives. These sort of facilities are going to be really important. So it's very powerful.
Yeah, I just to add to that, David, I think in the future, nowadays you go to a library and you borrow a book. I think in the future, maybe you'll go to the university library or the local library and borrow a robot. And this is what we'll need in order to bring up the skills of the wider population so that we can do the jobs of the future. We need to be able to have robots that people can access easily and learn how to use them. And I think that could be one way of doing it, borrowing a robot.
Yeah, that sounds like a great idea. Alex, go ahead. I know that you want to say something.
Yeah, I just wanted to add on top of that, actually, we were piloting this scheme before the pandemic hit. So we had blockers in the Diamond where we had 10 robotics kits, the MiRo, the laptop, and the TotalBot 3 robot. And basically anyone who has interest involved in these kind of courses, they can just come in and borrow them for a limited time. Obviously now it's very tricky because you have to clean up everything and kind of postpone that for now.
But that's just for now. I mean, there's a lot we haven't touched on here. I mean, there are things I know Alex you talked about before about the ways you can at least see how many hours on MiRo the students have been using, in order to see what their progress is. And I think for the future, one of the things we're thinking about is what are the other kind of assistance that we can put in there for academics, teachers, educators, to help them do assessments, both summative and formative, on the students as they go through. So there's things for the future that we want to do, and we're sort of learning a lot from Alex's experiences to help us think about that. So great. So listen, thanks very much, Alex and Tony. It's been a very interesting half an hour, at least, probably. And it's been good to see MiRo being used in action at scale. And I think what you're doing, Alex and Tony as well in particular, it's the future of learning. And well done.
Thank you, David.
Okay, great. See you next time. Bye.
Bye.
Bye.